Hello geometry students, this is Ms. Doolittle, and this video is on identifying transformations between two figures. So let's go ahead and get started on these slides and get you ready for your quiz. All right, so on this past Wednesday, we talked about isometric and rigid transformations. So here's the thing, isometric or rigid transformations, either word works to describe what we're gonna do. There are several different types of transformations, and 3 of those types of transformations are not going to change the object's shape or its size. So when we do not change the object's shape or its size, it is referred to as an isometric transformation or a rigid transformation. Either one of those words works, it means pretty much the same thing, okay? So the first one of those is a translation. Remember, this is all review. We talked about this in class last week. Well, the translation, what I'd like for you guys to think about, let me get my pen turned on here. What I would like for you guys to think about is the SL in translation should remind you of the word slide, okay? So really what we're gonna do is we are gonna take this figure and we are going to slide it over to the right so it can be under image 1. Now I can slide it up or down as much as I want as well, but the point is if all you're doing is sliding this figure around, this is considered a translation. Now, for image 2, now for our purposes here, just so I can put it underneath image 2, I'm going to have to translate it, but really what my point is I want to rotate it, okay? So I'm gonna take this little curved arrow that's up here at the top, and I am gonna rotate this thing what appears to me to be 90 degrees. So that would be like right about there. Okay, so that would be a 90-degree rotation. If I rotated it up obviously another 90 degrees, then now I'm at 180-degree rotation, and so on and so forth. So you can rotate these things as much as you'd like. Anyway, that's an example of a rotation. That's what that looks like. Now, again, for the purpose of what we're doing here, I'm going to have to slide this thing or translate it so I can get it over into image 3's spot here. But this one I want to reflect. So right now you can see that this from this one to this one, that image has just been translated right now. But what my point is I want to be able to show you what it's like to reflect it. Okay, so I'm going to use this rotate tool up here at the top. I think you guys can see that on your screen. And whenever it says rotate, that's doing what we did for image 2. What I want to do is flip the thing. Okay, so here's the original. Now if I flip that vertically, that would be like flipping it over the x-axis. I don't have a coordinate grid here for you to look at, but that's what that would be like. So do you guys see what happened? It flipped it upside down. Okay, so that's a vertical flip. Now, from the original, I could also flip it horizontal, so that would be like flipping it over the y-axis. So you seeing what happens there? Okay, so let's go ahead and go with our horizontal flip. Just wanted to show you that what that looks like when you have a translation, just simply a slide, a rotation, it's where we rotate it around like a hand on a clock, or a reflection, which is where we flip that thing like you're looking at an image in a mirror. Okay, all right. Next slide, there is another type of transformation. This one is called a dilation, okay? Now, a dilation is either an enlargement, so here's my pre-image of the turtle, and then I blew it up and made it larger. You can see it's exactly the same shape, okay? All I did was make it bigger. So I can also reduce the figure down. I can take the turtle and I can make it a little bit smaller, which is what I did down here. Again, its shape stays exactly the same. All I did was shrink it down. All right, so is a dilation an isometric transformation? Remember, an isometric transformation does not change the object's shape or size. Well, in a dilation, we are changing its size. That's the whole purpose of a dilation. So that means it is not an isometric transformation. Okay, so we can't use the word isometric with this because we are changing its size. So no, this one is not an isometric transformation. All right, scale factor. Now the scale factor, when you're working with a dilation, a scale factor is going to tell you how much an object is enlarged or how much it is reduced. And the one that's in black ink is the pre-image, so that's the original, okay? The blue one obviously is a lot bigger, and they're telling us up here that this one was a scale factor of 2. So it was blown up by a scale factor of 2. That just means all of its dimensions were doubled, okay? And then the smaller one that's in red, that took the original one and shrunk it down by 1/2. So it took all of its original dimensions and shrunk it. It cut them in half. But it turns out to be the same exact image, but just smaller, just half the size. And this one is the same exact image as the original, but twice the size. Okay, so that's what a scale factor does, is it tells you exactly how much this thing is being enlarged, or exactly how much it's being reduced. And I believe, for those of you that are artists out there, I am not one, but for those of you that are artists, I believe this is a technique that's used in art, where you put something over, you put a picture on a grid like this, and then you can blow that up and enlarge the squares themselves, and then draw within those same squares. So you can see the little piece of the elephant's ear here is going to match the little piece of the elephant's ear here, but you just draw it within a square that has double the dimensions. And in this one, same thing. The little piece of the elephant's ear here is within the same square. It looks just the same within this square, except this square has dimensions that are half as much as what the original one was, okay? All right, now to get us some experience with this, just another type of example, what I did was I put this @ symbol in a text box, okay? So this is what we're going to consider my original, okay? This is my original size, and it has a scale factor of 1. So if you ever see anything that has a scale factor of 1, that means it's 100% of its original size, right? So it's exactly the same as it was. So, and I wanted to tell you what the font size is on this. This one had a font size of 60. There's a reason you need to know this, okay? So I've got a couple of copies of this thing already here on the screen. So I'm just going to move this one over. Now the first thing I want to do to this is create a scale factor of 1/3. So I want this one to become 1/3 as much, 1/3 as big as the original. Well, here's why I told you the font size, right? Because if we take this font size and we shrink it down to 1/3 of its original size, that basically just means that take that 60 and divide it by 3. So that means my font size would be a 20. All right, and look how much that shrunk that thing down. So it is, theoretically, it looks a little squished actually vertically, but it's supposed to be the exact same shape. It's just this one is 1/3 as big, all right? Okay, so now we're gonna go over to this other side, and we are gonna implement a scale factor of 3, okay? So if my original font size was 60, and now I want to implement a scale factor of 3, that means I'm going to have to take that font size of 60 and multiply that by 3. So that's going to give me 180. So watch what happens here. That thing gets huge, all right? So this is just, like I said, one more example of that scale factor and what that can do. So scale factor of 1/3, scale factor of 1, or in other words, the original, and a scale factor of 3, all right? Okay, now which transformation is it? And what we're looking at here is your A and B, this little oval down here. I'm gonna move around just to circle our answer. But what I want you guys to do is tell me, what is the transformation that created image B from my pre-image A? So starting with A, what did we do to A to get B as a result? Go ahead and pause the video and try to answer that now. Okay, and hopefully you guys saw right away, well, this thing changes size, right? So it has to be a dilation. There's really no two ways about that. Now, they just showed this to you off to the side. That was the purpose of this particular example. But the truth of the matter is that image was also slid over to the right, okay? So technically, it is also a translation. So we not only made the square bigger, but we also slid the thing over to the right to put it in the position of B. So technically, this is a multiple transformation where we have both a dilation and a translation. Okay, again, this is just to highlight our answer. So for this one, from my pre-image, the one that's in the yellow color, right, to the image that's in the green color, I would like for you guys to tell me what type of transformation is that. Okay, hopefully you had a chance to get that worked out. Of course, anytime that I prompt you to do that, you want to press pause in case I don't tell you specifically to press pause. So this one, what you want to think about, it's first off, it's about a point, right? Because we've got point A there in the middle. So if we take this corner where my cursor is sitting right now, and you think about that being on the hand of a clock, right? Let's say it's on the minute, the end of the minute hand of a clock, and that thing goes around the clock, and it ends up right there. Okay, so whenever you think about something traveling along the hand of a clock, or traveling, as the tip of the hand of the clock moves around the circumference of the clock, you're going to think about that as being a rotation, because that's what hands of a clock do, as they rotate around the center point. Okay, so this one is a rotation. If we take this corner here and we rotate it, we end up with this location down here. Okay. All right, how about this one? What do you think this one is? Go ahead and press pause. Okay, hopefully you had a chance to take a look at that one. That one is actually a reflection. We took the red one and reflected it across line M to make the blue one, or vice versa. In this case, it doesn't really tell me which one is my image and which one is my pre-image, but the point is one is being reflected across line M to create the other one. All right, and then we have this one. If you want to try to take a stab at this and see what you come up with, go ahead and press pause now. Okay, hopefully you had a chance to do that. I just have to say this up front, is that sometimes these transformations, there are multiple different ways to end up from a pre-image to an image. So the way that I describe this to you is going to be accurate, but that's only going to be one of the possibilities, right? So there could be other possibilities that you see that you say, well, I think, like the way I see it, it could be fill in the blank, and you very well could be right. Okay, there are multiple different ways. In some cases, this really is in the eye of the beholder. There are some things that you could say that would absolutely be incorrect, but in lots of cases, when I've taught this over the years, I've had students say, well, wouldn't that be the same thing as doing fill in the blank? And in a lot of cases, those students were right. So anyway, for this particular example, the way that my brain processes this, what I see is if the B were to tilt up this way, the A were to tilt down this way, that is a little bit of a rotation, right? So I am definitely seeing a rotation happen here. But then when I rotate it, so the B is up and the A is down and the C is pointing out to the right, that still doesn't get it over to this location. So I definitely see a rotation, but then the way I'm seeing it, we would also have to translate that over to the right, or slide it over to the right to end up with our triangle, our ST. Okay, now we need to take a look real quick at multiple transformations. And in Accelerate, they talk to you guys a little bit about this thing called a glide reflection. And a glide reflection is just simply a translation along with a reflection. Okay, so it's a combination of a translation followed by a reflection. It doesn't matter which one you do first, reflect or translate. Either one is the same thing. So here's the thing. I never thought about this before I found this image online. And if you think about when you're walking, right? So if you stand up right now and you're in your bare feet, right? So you stand up and look at your feet on the floor. You can see that your feet are actually reflections of one another, right? So your right foot and your left foot are just reflections of one another across that center line. So, and then as you're walking, not only is one foot a reflection of the other foot, but you're also translating, right? You are sliding basically your feet across the floor in a sense, right? So if you look at footprints in the sand, right? So for instance, you would see, the left footprint And then the reflection would be the right footprint, because the right is a reflection of the left, but the right would be moved forward. So that is what creates that glide reflection. So we've got both the reflection going on between the right and the left foot, and you've got that translation of the different steps if you think about footprints being in the sand. Okay? All right. Okay, so a few more examples where we want you guys to describe. I've got 4 more slides where we just do examples together. So describe the transformations. So there are going to be 2 of them, 3 of them actually in this particular example. So go ahead and press pause now and see if you can come up with those. Okay, I hope you had a chance to get those figured out. The first thing that I see, we're starting off with triangle ABC. That's the small one, because remember, it doesn't have the primes written in. So this is how we know it's the pre-image. And it's smaller, so then we end up going to one of these bigger triangles. So right away, the first thing that draws my attention is that thing got bigger. So I'm definitely talking about a dilation, pardon me. So then it appears to me that not only have I blown this thing up and made it bigger, but I also had to slide it up. Well, a slide is a translation. And that's those 2 things together, the dilation and the translation, that's what would get me to A prime, B prime, C prime, which is my first image. Okay? Now when you think about going from the first image to the second image, you can see that, for instance, if we look at A prime, we can see that we are 1, 2, 3 units up, and A double prime is 1, 2, 3 units down. So it looks to me like this thing has just now been reflected across the x-axis to make our second image. So we've got a reflection going on as well. Okay, so again, when you have multiple transformations going on, it does not necessarily matter which one happens first and which one happens second. That being the case, we could definitely say that instead of, saying it's a translation into reflection, well, that is the definition of a glide reflection, right? So it's just those 2 things kind of grouped together. So you could also say it's a dilation with a glide reflection. Either way is fine. That might be a little bit harder to argue in this case because we have the first image and the second image, but getting from the pre-image to the second image, though, we could definitely argue that there is a glide reflection involved. Okay, next slide. Again, if you guys would like to pause the video and see if you can figure out what are the transformations that go from the pre-image to the image. And by the way, the pre-image in this case, in the next 3 slides, are going to be the purple-ish ones. Okay, and then the image is going to be the gray. Go ahead and press pause now. Okay, hopefully you had a chance to get that worked out, and here's what I see here. So if we take this one, I made an image of this thing on purpose. The first thing that I happen to see on this one is that my image over here in quadrant 1 is pointing down. So obviously, in order for that to happen, I would have to rotate this thing and make it point down. So that would be a 90-degree rotation, all right? So rotation for sure. Alrighty, now if I take that thing, oh shoot, that's not what I wanted to do. Now if I take that image and I move it over, all I'm doing is translating it or sliding it, and I can make it go right over top of that. So now you can see that that was not only a rotation, but it was also a translation. Okay, now I could have some people out there saying, well, in this case, it looks to me like, yes, I see the rotation, but couldn't you have also reflected it? Did a rotation and a reflection? Yes, that's another possibility. I absolutely could have done that, and I haven't checked to see if the numbers would work out exactly for that, but so it could be a reflection across the y-axis, but if the images have to be equidistant from the line of reflection. So if by chance that part doesn't work out, you would just shift that line of reflection. Instead of saying that it's the x-axis, it might be off just a little bit to the right or to the left, but I didn't check that one out. Anyway, if you saw a reflection out of that instead of a translation, you are not incorrect. That very well could be the case. All right, here's another one. Press pause and see what you come up with. Okay, hopefully you had a chance to do that. On this one, again, one of the very first things that I see is that one of the gray one is much larger than the purplish one. So clearly we have a dilation going on here. So definitely made the thing a little bit bigger, okay? So let's click on that. Yeah, I've got an image and a pre-image. Just wanted to make sure I had that set on there. So if I enlarge this a little bit, I'm not sure I'm going to get it to the exact same size, but I'll give it a try. All right. So, and then in this case, what I would have to do, just because I'm limited, this thing could technically be reflected across the y-axis. I don't have the tools to do that on PowerPoint, but if I did, let's see, if I said rotate and said flip horizontal, then that sets it where I need to set that, right? But that's just reflecting it across a center line of the image itself. And then in my case, I would have to translate it or slide it over to the right. Some people, as you were looking at this, you may have seen, hey, that's just, it's a dilation, and then I can directly reflect it across the y-axis. So you might have said dilation and reflection. We could technically get away with saying dilation. Get my pen turned on here, sorry. Okay, we could have said dilation and reflection. You could have also said dilation, reflection, and translation based on particularly the limitations I have here in PowerPoint. All right, last one. Okay, I'd like for you guys to see if you can figure this one out. So press pause and we'll check when you get back. Okay, my hope is that you had a chance to do that. And this one, a lot of people are probably going to see, you're either going to see, there's two different ways at least that I see this right now. You're either going to see a reflection, because clearly it could be reflected across the x-axis, be reflected down here. And then, you know, you could see a double reflection, so reflected down here, and then again reflected across the y-axis, so across the x and then across the y. So a double reflection is one possibility. A second possibility is you could have seen a reflection and then a slide, right? So a reflection and then a translation. Yet a third possibility could be that, like, if you see this heart, again, think about it being on, like, glued on to the tip of the minute hand of a clock, and then it rotates around the center of the clock. This technically could also be just a rotation, just simply a rotation. So you've got three different possibilities for this one. Rotation being one of them, double reflection being one of them, and a reflection and a translation being another one, okay? Now, those things being said, that was our last example. When you guys take the quiz, I don't recall seeing a lot of them on the quiz where there were multiple possibilities like you saw in this example, at least not the ones that the system pulled up whenever I went through it. If you happen to see that and you think that you answered them correctly and you're able to justify your answer that you gave, but the system marks you as being incorrect, make sure you email me and we'll chit chat about that just a little bit. And if there are points that need to be given back to you, I'll be happy to do that, okay? All right, guys, I apologize for the lengthy video, but thank you so much for watching and we'll talk to you soon. Bye-bye.